Hello guys, so today we will learn about phenol. So let's start. Phenol consists of a hydroxyl group that attached on benzene ring. In real life, phenols looks like white crystals like this. If we see the preparation step of phenol, then first method of preparation is DOS process. Here, chlorobenzene are passing in presence of sodium hydroxide in acidic medium at 623 Kelvin and 300 to 320 atm pressure to form phenol. If we see mechanism, then in the presence of acid, NaOH will dissociate into NaO minus and H plus, and Cl minus is more electronegative, so it will dissociate into Cl minus, and here there will be electron deficiency. And this is electron rich, so this will attach here and form this. And in the solution there will be Cl minus also and H plus, and Na plus will form bond with Cl minus to form NaCl salt, and H plus will attach to O minus to form phenol. Our second method of preparation is from benzene sulfonic acid. Here benzene are treated with oleum to form sulfonic acid, and sulfonic acid is further treated to sodium hydroxide in acidic medium to form phenol. Third method of preparation is from diazonium salt. Here aniline are treated in presence of NO, NO2 and HCl at 0 to 5 degrees Celsius to form benzene diazonium chloride, and in presence of warm water this changes to phenol and N2 and HCl. Our fourth method of preparation is from benzene, and benzene is oxidized in presence of V2O5 and 300 degrees Celsius condition, and this benzene is converted into phenol. Our fourth method of preparation is from cumin. When cumin are reacted with oxygen, we are getting this product, and on further treatment with water in the acidic medium, we are getting phenol and CH3 C double bond of CH3. If you see mechanism, then this mechanism is basically free radical mechanism. Here mm, O2 is dissociated as the free radical, and because of this free radical, others component also dissociate into free radical like this. CH3, CH3, C as free radical and H as free radical, and this oxygen has a lone pair and the free electrons also, and this will try to find form bond here, and H plus will be formed here from the backward side and will form this product. And if we pass in the acidic medium H plus, then it will form the bond with oxygen because oxygen has localized electron, and this will form water, and this water will be separated out as this, and some rearrangement of this product occur, and we are getting this product. And in S3 medium, this is separating as CH3 C double bond of CH3 and OH minus are attaching to benzene to form phenol. This is one question here. Benzene are treated with Cl, CH2, CH2, CH3 in presence of AlCl3 to form product P, and P are further treated into O2 in presence of heat to H3O plus to form Q and phenol. As this is the same reaction of above, so this is phenol, so Q will be CH3 C double bond of CH3. This will be the same product, so we are getting Q as this, and this is the feedback of the alkylation reaction where Cl minus will be separated out, and we are getting electrophile, and there will be a rearrangement of electrophile carbocation to here, and we are getting stable carbocations as CH3, CH carbocation and CH3, and this will attached here to form this type of product. So Q is this and P is this. So this is the correct answer. Let's see physical properties of phenol. First property is boiling point. Boiling point of phenol occur because of van der Waals forces, and with the increasing carbon atom, boiling point increases, and boiling point decreases with increase in branching, as increase in branching defavors van der Waals forces. Second property is solubility. Due to hydrogen bonding, alcohol and phenols are soluble in water, and solubility decreases with increment in carbon, because as increment in carbon we are have steric hindrance and there will be less hydrogen bonding. Let's see chemical properties of phenol. First is acidic nature. When H plus ions will dissociate from phenols, then we are getting a stable product as PHO minus, and here conjugation will be there and this will be more stable, and that's why phenol are very much acidic. And if we see the relative acidity, then PHOH is highest among all these: PHOS, CH3OH, H2O and ROH. And this is the reaction of acid and metal. So acid and metal reacts to form salt and hydrogen. Then this acid reacts to the sodium hydride to form salt and the hydrogen. Acids are reacting to base to form salt and water, and this PHOS as treated as acids are reacting with the NaNH2 to form salt and NH3. Second reactions are electrophilic substitution reactions, where electrophiles are generated, and this electrophile substitute hydrogen and attach on the phenol rings. And the first method is nitration. Here phenols are treated with dilute HNO3, and here NO2 plus electrophile are generated and it replaces H plus on the ortho and para position to form orthonitrophenol and paranitrophenol. And if we treat phenol with the concentrated HNO3, then it will activate both ortho position and para position to form picric acid. And second reaction is halogenation reaction, where we are doing bromination, and if we are passing Br2 in presence of CH2 at 273 Kelvin, then we are getting bromo at ortho and para position of phenols to form monobromo phenol and para bromophenol, where para positions are major and ortho positions are minor. Whereas in the second, when we are passing through 3Br2 and water, then bromine will attach to both the ortho position and para positions. Third reactions is sulfonation, where phenols are treated with concentrated H2SO4 at 25 degrees Celsius. SO3H are adding at ortho position, and at 100 degrees Celsius SO3H are added on the para positions. This is one question that came in JEE 2002. What is the structure of major product when phenol are treated with bromine water? And this is the same above reactions of 3 bromine and water. We are getting this. So this A will be your answer. Let's proceed to the more chemical reaction of phenol. Next reaction is Kolbe reaction, where phenol are passing with sodium hydroxide and CO2 in the acidic medium to form salicylic acid. And if we see mechanism, then here H plus in the acidic medium, H plus is moving out, and pi bond of here are switching toward oxygen, and we are getting electrophile, and these electrophile are attaching here to form this compound, and here this is sp3 hybridized, and from the conjugation this is going into non-conjugate, so this is not much stable, and that's why H plus are separating out and we are getting this, and H plus are then attaching to here and here to form salicylic acid. Next reaction is Ramer-Tiemann reactions. Here phenol are treated with CHCl3 in aqueous NOS to form this product, and if we further treat it with sodium hydroxide, then CaCl3 will be ClCl will be replaced with OH, and all Cl3 will be replaced with 3OH, and there will be substitution 2OH into substitute into double bond O, and we are getting CHO. And in the acidic medium, we are getting cycaldehyde. The next reaction is reaction with zinc. Here phenol are treated with zinc, and here reduction of phenols occur, and in this we are getting benzene and zinc oxide. Next reaction is oxidation of phenol. Here phenol are treated with NO2 Cr2O7 or by air in presence of acid to form benzoquinone. This is the NO2 Cr2O7 is oxidizing agent which oxidize phenol. Let's see some of the test of phenol to confirm the presence of phenol. First one is natural FeCl3 test. When phenol or passes through FeCl3, it forms FeOPS to the power 6 3 minus ions, and this is a coordination compound which are violet in color, and this violet in color confirms presence of phenol. And second test is bromine water test. When phenol or passes through bromine and water, this form this white PPT. This white PPT, and this also confirm the presence of phenol in solutions. And this is all your phenol chapter. So let's proceed to the question part to more confidence in this subject. First PYQ that comes in JEE Mains 2025 is what amount of bromine will be required to convert 2 gram of phenol into 2,4,6 tribromophenol. So we have reaction like this. We have phenol, and we are reacting with 3Br2 to form this product. And 1 mole of phenol will react to 3 mole of bromine. And because of this, let's calculate moles of phenols used. Moles of phenols usage here. Okay, so moles of phenol is 2 gram divided by molecular mass of phenol, that is 94, and we are getting 0.021 mole. And moles of Br2 will be 3 times moles of phenol, so it will be like 3 into 0.021. So mass of Br2 needed will be equals to molecular weight of Br2 into moles of Br, and molecular weight of Br2 is 160, so 160 into 3 into 0.021 will be equals to 10.22 gram. So this will be our answer. Our second question is that statement 1, the boiling point of alcohol and phenol increases with increase in the number of carbon atom, as we have earlier see that this is true, and boiling point of alcohol and phenol are higher in comparison to other classes of compounds such as ethers and haloalkanes. Yes, this is also true because in these reactions there will be more vulnerable forces of alcohol in alcohol and phenol as compared to ether and hydroalkanes. So statement 2 is also correct, statement 1 is also correct. So in this question B will be correct answer. Our third question is that benzene is treated with oleum to form a compound X, which is further treated with molten NaOH in the acidic medium to form Y, and this further treated to Zn to form Z compound. And if we see clearly, then this is the method of preparation for phenol that we have discussed. like method of preparation of phenol by the sulfonic acid. Then the X will be the sulfonic acid and Y will be phenol. And this is the reduction reaction of phenol with the ZN to form benzene as we have seen here, as we have seen here. So compound Z will be benzene. Compound Z will be benzene. So our correct answer will be C, benzene. Let's see some more question. In list 1 we have reaction and in list 2 we have reagent. And this is phenol converted into salicylic acid, and this is the reaction of Kolbe as we have discussed here, and we have discussed here in the presence of NaOH, CO2 and acidic medium, phenol is converting into salicylic acid. So this will be like NaOH, CO2 and HCl. So A will be fourth, and B is like phenol is converted into this salicylaldehyde, which is the same Raymond-Diamond reaction that we have already discussed here. And in this CHCl3, NaOH and H plus is also taking. So this is the reagent. And if you see here, then this is NaOH and this is CHCl3 and this is HCl. So P comes here, and this is the oxidation reaction that we have seen in the chemical reaction of phenol here. So in this reaction, reagents are Nr2, Cr2O7 and H plus. So we are getting Na2Cr2O7 H2SO4. So C will comes here and the remaining D will comes here. And if you match, A comes in fourth, B comes in third, and C comes in first, and D comes in second. So D will be your answer. And phenol treated with chloroform in presence of sodium hydroxide, which further hydrolyzed in presence an acid reaction. This is a standard Raman-Diamond reaction, and which basically generates salicylaldehyde. So D will be your answer. Salicylaldehyde with synthesis from phenol is treated with this is the same question, and here we are getting here we are taking CHCl3 as here we are taking CHCl3 as reagent, and this is the same question, CHCl3 and H plus and NOH will be your answer. So CHCl3, CHCl3, HCCl3 and NOH will be your answer. And this is some more questions that phenol is treated with Zn and delta. This will reduce into benzene, and phenol is treated with CaCl3, NOH and HCl. This will treat into a salicylaldehyde, as this is a Raman-Diamond reaction, and phenol with reaction to the CO2 and HCl. This is a Kolbe reaction, and this will goes to picric acid, and phenol and concentrated HNO3 will be moves to picric acid. So this will be after matching all these questions, we will get C as your correct answer. And this is the this is the last questions. And here we are getting phenol converting into this salicylaldehyde, and phenol is reducing into benzene, and phenol is oxidizing into benzoquinone, and phenol is converting into a monobromophenol. So after seeing above the reaction, we can see that this is the bromination, this is the bromination, so this will goes to here, and this is the oxidation, this will goes here, and this is the reduction with Zn, so this will go here, and this is the remaining part. This is basically CaCl3NOH. So after this we are getting A into fourth, A goes into fourth, and B goes into third, and C goes into second, and D goes into first. So one be your correct answer. So you can also solve more question based on this topic. and question in mains are mostly like that. So let's meet in the next class. Thank you. Bye.